Has this ever happened to you? You're getting ready to have friends over for dinner and you're rushing to get everything completed before they arrive. You've got all the lights on, your oven is cooking food, your music is blaring, and you're blow drying your hair. All of a sudden, everything turns off and you're left in the dark. This happened because you overloaded the circuit that ran the lights, oven, radio, and hairdryer. A circuit is a path that electrons can flow through. It's what provides electricity to your lights, oven, radio, hairdryer, and other things in your house through the outlets you plug them into. There are two ways that items are connected along a circuit, in series or in parallel. A parallel circuit connects devices along branched pathways, which provides separate paths for the electrons to flow. A series circuit connects devices in series, providing one single pathway for electron movement. We'll explore parallel circuits in detail in another lesson. For now, we'll focus on how series circuits work to power devices. Think of a series circuit like going through airport security. In order to get to your plane, you have to stop at a series of checkpoints and do so in a certain order. As long as each station is open, you can move through the checkpoint path quite easily. But if for some reason the hallway leading to the next station is closed, say for construction, you have to stop and are no longer able to get through to your plane. This is true for a series circuit as well, but the terms are reversed. A closed circuit is a circuit with current flowing through it, and an open circuit is a circuit with no current. We say the circuit is closed or open, but really we're talking about a switch being closed or open. If the switch is open, the loop isn't connected, so there's no current. But if we close the switch, we complete the circuit by closing the loop so current can move through it. Closing or opening the circuit is as simple as flipping a light switch. When you flip the switch to the on position, this completes the circuit and closes the loop, supplying current to your ceiling lights. When you flip the switch to the off position, you open the circuit and no current flows through to the lights. We can construct a simple series circuit with a battery and a few light bulbs. When the switch is closed, the circuit has current and the light bulbs light up. The current flows through each bulb from the negative terminal of the battery to the positive terminal. And because there's only one pathway, the current is the same in every part of the circuit, even the battery. But what happens if you break the circuit? Well, the flow of electrons stops and there is no longer any current in the circuit. If you open the switch or one of the bulbs goes out, the whole circuit is affected. This is the same reason why a string of Christmas tree lights won't work if only one of the bulbs is burned out. They're all connected in series, so the current stops flowing to the rest of the bulbs as well. You may have noticed that the more lights you connect to a series circuit, the dimmer each light becomes. This is because each light bulb provides resistance to the current. This is an opposition of electron movement through the device. As it encounters each bulb, the current is resisted by the resistance of each bulb and has less energy as it travels to the next one. Let's go back to the airport to see how this works. Your first stop is the front desk, where you print your tickets. Here, you have to show your ID and drop off your bags. The next stop is the ID check station. Here, you show an officer your ID again, as well as the ticket that you just picked up. After this, you go to the X-ray screening line, where you again show your ID and ticket, but now you also send your carry-on and other items through the X-ray machine. It seems sort of redundant, and each time you have to get your ID out and show it to someone, you lose energy. It's simply exhausting going through all of those ID checkpoints. Electrons experience the same thing as they pass through resistors. It's like showing their ID to each of the light bulbs as they pass through, and they get tired of doing so and lose energy as they move along the series. What's really important about the resistance in a series circuit is that the total resistance to the current is the sum of each individual resistance along the path. So each